Okay, this first one here. What does adding another substance to the properties of a metal? How's this accomplished?
Some of its properties.
Okay.
You're adding to the metal. This is probably one of the harder ones. Oh, I thought those were hand warmers for some reason.
Is that better? No. No, that's not better either. Maybe if I plug it in. Just a chance that could help. It imparts some of its properties on the metal. In terms of interstitial defects, what do we say with that? What do you want to say about that? What? No, just like how is this accomplished in terms of interstitial defects? What were besides the vacancies, what are the other two types?
Big one. Yeah.
Substitution deals with things like the substitution basically just changes oxidation properties and hardness. So make it harder, make it softer, or make it less likely or more likely to rust. And what about, what's my other one? Substitution, vacancy, substitutions, and so it increases the strength but loses flexibility. Okay. What?
I know what you're talking about. There's that one like. Yeah.
Mm-hmm. Passed it. We got these backwards. Mm-hmm. Okay. What's ionized salt? Okay, so regular table salt, iodized salt. They add it to regular salt for what reason? Okay, so it's about thyroid issues that make sure everybody gets enough iodine in their diet. So goiters are the most common issue with that. But talk about these two ions. Really? 17 protons versus 53 protons. So this is going to have 18 electrons, and this is going to have 54 electrons. So in a regular crystal matrix structure, what's the iodine going to do if I try to throw that in there? It's going to be too big. Right. No, the interstitial one was the too big one.
No, man.
Substitution. Is it important with this?
I don't think so.
It's not at all, right? Because we're not using salt to be flexible or strong. We're just dissolving it into our system, so it's not important. Well, why the X-rays instead of one of the other?
The wavelength to like the solids and not bounce off.
So wavelengths are correct length. They're atoms are about the same size as these. So then if I just vary the X-ray lengths, so when I say X-ray, it's not just like one wavelength. It's many X-rays that constitute, it's like blue is a range of colors of blue. X-rays is a range of wavelengths. So I just pick particular wavelength that, or I vary the wavelengths until I get the wavelength that's correct for the correct kind of interference that I want in my Bragg's equation. Lambda. You spend more time in fraternities or sororities, or just never do that. How many atoms fit inside the CCP unit cell? What's special about the type of unit cell? 4 and special? Is it 74%? 74% atom. %. Yeah, and these guys all have the same properties. Pythagorean theorem. Right. So we've got A and B and C. And so even though the atoms don't touch each other on the corners because there's a space in between, they do touch each other going down the diagonal. So then I can use A squared, B squared, C squared. And then when I get my C, what's my C equal? 4, yeah, 2 atoms or 4 radii. Yeah. Solutions. Give me a liquid one. No, that's not a solution. That's pure substance. Okay, first off, it's been said already, like 8 seconds ago, maybe 4 seconds ago, and second, it's still wrong. Solid? Did you say grass? Okay, good. Gas? Super easy. Air. Okay. Fundamental driving forces behind these solutions to be formed.
Increase in disorder.
This is chem for concentration.
Is that brackets?
Yeah. You put brackets around anything, it automatically means moles per liter. So you don't need to actually include the capital M unit. Uh, so we want less energy, and we want less, or we want, I should probably do more chaos. Does anybody remember that from a fairly famous movie from the very late 90s? No Star Wars there. The original Jurassic Park movie, or the text, or the book, I mean? No? Never read it?